All right, so we'll move over now to question 4. Question 4 says solve the difference equation. So we're given yn plus 2 minus 4yn plus 1 plus 4yn equals n squared. All right, so this is actually a homogeneous and an inhomogeneous differential equation mixed together. Now, to solve this problem, first of all, we say let yn plus 1 be equal to the n in this case, because y is changing with respect to n. That's the essence of this n values you're seeing here. If it was yx plus 1, it would have been dy dx. But then we can simply call that y prime prime. Okay, sorry, y prime. That's for yn plus 1. And let yn plus 2 be y prime prime. And then yn be simply equal to y, just to reduce the whole unknown variables there. Okay, so if we do this, in place of yn plus y, we'll call that, so in place of yn plus 2, we call that y prime prime plus, in place of, okay, sorry, minus, it becomes minus now. So I have minus 4yn plus 1, so it becomes minus 4. Okay, please, this is minus. All right, so yn plus 1 is called y prime plus 4. Yn here is simply called y, and this is equal to n squared. Now, this is both homogeneous and an inhomogeneous differential equation. So what we'll do is we'll pick the homogeneous part first. So call this equation 1, considering the homogeneous part. All right, so the homogeneous part is simply what? The whole of this part equated to 0, not including n squared, is called the homogeneous part. So we simply have y prime prime minus 4y prime plus 4y to be equal to 0. This is the homogeneous part of the differential equation. Now, to solve this equation, we say let y be equal to a exponential m n. Now, it's supposed to be a exponential mx, but since from the question we are seeing that y is changing with respect to n, that's what is given in the equation. That's why we're using a exponential mn, but n now becomes what? The independent variable, and y is always the dependent variable. So n is what you can simply call x in your differentiation. So what we need to do is, if we're saying y is equal to this, all we need to do now is differentiate y. Okay, let's find y prime prime and y prime. That's all we need to do. So we differentiate y. Y prime prime means differentiate double. So first of all, we'll differentiate the first, find the first derivative, y prime, and that's equal to, remember, differentiate the numerator. To differentiate an exponential function, first thing to do is differentiate the numerator. Use that derivative to multiply the exponential function itself. Numerator is mn, and the changing variable there is n. So if I differentiate m, okay, if I differentiate mn, I'm going to be left with what? Just m, because like I told you, n here can be likened as x. Okay, so if I have mx and I differentiate m with respect to, so if I have mx and I differentiate mx with respect to x, I'm going to have just m. Same thing happens here. If I differentiate mn with respect to n, I'm going to have just m. So use that m to multiply the whole exponential function. So I have a exponential m, and that becomes how to differentiate an exponential function. So notice that this can be equal to, or this can be simply said that y prime is equal to, because a exponential mn is what we just called y, then I have m multiplying that value. That means y prime is equal to what? M times y. I can keep this. Next, I'll find y prime prime, and that's equal to differentiating this function now again, because this is y prime. So if I differentiate y prime again, I'm going to have, now remember, I already have m here. Keep this m aside. Now differentiate the numerator with respect to n. If I differentiate mn, I'm still going to have m. So it becomes times m times a exponential mn. So differentiate an exponential. So to differentiate an exponential function, simply differentiate the power, use the derivative to multiply the whole exponential function itself. So I simply have this. Now m times m will give me what? So this implies that y prime prime is equal to m times m is m squared times a exponential mn. So notice now that once again a exponential mn is what we call y. So this simply implies that our y prime prime is simply equal to what? M squared y. So I simply have this. So if I have this for y prime prime, then all I need to do now is plug in these values for y prime prime, for y prime, and for y into um the homogeneous part of the equation, which is this. Okay, so we have, okay, which is this, sorry, into the homogeneous part of the equation, which is this. So remember, we have y prime prime minus 4y prime plus 4y equals 0. Now what is y prime prime? Y prime prime equals m squared y. So I will simply have m squared y minus 4y prime, and y prime give us my, so minus 4my plus 4y plus 4y, and that's equal to 0. So this is the homogeneous part of the differential equation. So notice now that y is common amongst all. This simply implies that m squared minus 4m plus 4 all multiplied by y is equal to 0. I have this. Now for this equation to be true, it simply implies that either y is not equal to 0. Of course, y cannot be equal to 0, else everything here becomes 0. Or I have m squared minus 4m plus 4 is equal to 0. So we now solve with this equation. Now this equation, m squared minus 4m plus 4 is equal to 0, is called the auxiliary equation. This is called the auxiliary equation. So we solve this by any method of factorization, either factorization method, quadratic formula, or whatever method you wish. But let me use factorization method here. So we'll look for two numbers such that when we multiply them, you can also use the general formula, mind you. Okay, let's use the general formula. I think that will be easier. I have here my a to be equal to coefficient of m squared, which is 1. I have my b to be equal to coefficient of m, which is minus 4. And I have c to be what, a constant, which is equal to 1. Therefore, I'm looking for m. M equals minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, so this is equal to minus, and b is minus 4. So remember, it becomes minus 4 plus or minus square root of. So I have b squared, and b is minus 4. B is minus 4 all squared minus 4ac, and a is 1, and c is equal to 4. Okay, times 4 all over 2a. A is also 1. So this implies now that I'm going to have m to be equal to minus minus is plus, so I have 4 plus or minus the square root of same thing, minus 4 squared here becomes 16. So this gives me plus 16, and 4 times 4ac becomes 4 times 1 times 4. That gives me minus 16 all over 2a. A is 1, that's 2 times 1, that's 2. And this is equal to 4 plus or minus. Of course, it becomes square root of 0 all over 2. And I have here to be root 0 is off. I have 4 divided by 2, and this is equal to 2. Now, these two occurs twice. Of course, it's plus or minus. If you go by quadratic formula as well, by factorization method, you also notice that these two occur twice. So you have plus or minus 2. Sorry. So you have 2. These two occurs twice. Therefore, m is equal to 2 twice. So 2 occurs twice. If you go by factorization method, you have these two to actually occur twice. All right. So this simply means when a root occurs twice, then the complementary solution, since root is real and distinct, since root is real and equal, please. So they are real and they are equal. Of course, double times as twice. They are real and they are equal. Therefore, the complementary solution of the homogeneous part. Okay, complementary solution YC becomes now, since they have the same, since the root appear twice and is equal, it becomes A plus Bn multiplied by exponential Mn. So this is equal to A plus Bn exponential M was given as 2. So you have 2. And so this is now the complementary solution or complementary part of the homogeneous part. So that's the complementary solution of the homogeneous part. Okay, so you keep this aside. We also have an inhomogeneous part there, not forgetting we have an inhomogeneous part in the equation. So from equation 1, you have y squared y prime prime minus 4y prime plus 4y equals n squared. N squared here is the inhomogeneous part. So for that reason, we'll find the particular solution of the inhomogeneous part. Okay, so we considering the okay from equation 1. Let's fall back from equation 1 and solve from there. From equation 1, we have y prime prime minus 4y prime plus 4 to be equal to n squared. What's wrong with me? Sorry about that anyways. All right, so to be equal to n squared, that's the equation, the base equation. Now, like I told you, n squared here is the inhomogeneous part of the differential equation. So because this is squared, we now answer, we need to find the particular solution. So to find the particular solution of the inhomogeneous part, okay, since it is set as, since you have the inhomogeneous part to be n squared, you simply say let y be equal to cn squared. Okay, since you have the inhomogeneous part to be n squared, therefore let y be cn squared. So what you do now is we have to now find what reproduce everything here in this equation. So we'll find y prime prime, we'll find y prime and substitute into the base equation and see what we're going to have. So if y is cn squared, therefore y prime means differentiating y the first time with respect to n, it becomes 2 times cn. Okay, also y prime prime means differentiating y prime now again. If I differentiate n is off, I'm left with what? 2c. So I will now substitute these values into the original equation. So substitute y prime prime and y prime into equation 1. So if I do that, I'm now going to have from equation 1 we have that y prime prime minus 4y prime plus 4 is equal to n squared. So y prime prime is what? Y prime prime gave us 2c, so you have 2c minus 4y prime. Y prime gave us 2cn, so minus 4 times 2cn, okay, plus 4y and y, we said let y be cn squared, so plus 4cn squared, and the rule of this is equal to n squared. Okay, so this is equation 1. Let's now expand. This gives us 2c minus 4 times 2 is 8cn plus 4cn squared is equal to n squared. So at this point, what we'll do is compare coefficients. So comparing coefficients, so if we do that, of course, what I have on the right hand side is n squared. So I have to compare terms with n squared. So I have here 4cn squared to be equal to n squared. So from here, I can divide both sides by n squared. So n squared goes here is 1. N squared goes here is off. So this simply implies that 4c is equal to 1. And hence, I can find C. C is equal to now what? 1 divided by 4. Simply dividing 2 by 4. This gives me the value of C. Alright, so if this gives me the value of C, recall we said earlier that let y be equal to Cn squared. Okay, so now we know the value of C. This simply implies that y is equal to, in place of C is 1 all over 4n squared. This is called the particular solution of the inhomogeneous part. This is called the particular solution. So that's the particular solution of the inhomogeneous part. Now, if you have this, to find the general solution of the difference equation, okay, the general solution becomes the general solution of the difference equation, okay, is now the sum of both the particular solution or the complementary solution plus the particular solution. Okay, this gives us the general solution. Hence, the answer to that differential equation becomes, remember the answer we obtained for the complementary solution was this. So you put it down, a plus bn exponential 2n plus the particular solution. Particular solution gave us 1 all over 4n squared. So this is the answer to that difference equation. So that's it on question 4. I will see you in the next question on question 5. Thanks and cheers.